So welcome to Purnang once again. So how did you try this question, bachcho? See, you have a series, sum of terms, n terms, infinite terms, how many terms, doesn't matter. In any other function except algebraic, like inverse trigonometry, any other function. So my suggestion is, of course here general term is given, my suggestion is try your best to convert it to the general term, to the difference of two consecutive terms, bachcho, and particularly in inverse trigonometry and trigonometric series, है ना? So you should be very clear about it. Okay, so I won't even think anything else. Whenever I will get such a question, I won't even think anything else. I will just try and focus in converting the general term as difference of two consecutive terms here. Okay, so let's start. So therefore S is summation R goes from 1 to n tan inverse of 2 raised power r minus 1 upon 1 plus 2 raised power r into 2 raised power r minus 1. So now you may ask that how come I know that I have to write 2 raised power 2r minus 1 as 2 raised power r into 2 raised power r minus 1. See, I have that formula at the back of my mind which says tan inverse of a minus tan inverse of b. What is it? So it is tan inverse of a minus b upon 1 plus ab. So the focus here is 1 plus a into b. So I wrote that term 1 plus this term as product of two terms, 2 raised power r into 2 raised to the power r minus 1, and it's not like, so you can say okay, we can write it in so many different ways. Yes, of course, but then another thing is, of course, a minus b here. So in numerator I need a minus b, so the difference has to be equal to this. So let me write it again. So therefore I will say S is summation where r goes from 1 to n. See, I will write my numerator as 2 raised power r minus 2 raised to the power r minus 1 upon 1 plus 2 raised power r into 2 raised power r minus 1. Okay, so now when you solve this numerator, bachcho, you will get 2 raised to the power r minus 1, which you can easily check. See, I will take 2 raised power r minus 1 common, so 2 minus 1, which is nothing but 2 raised power r minus 1. So numerator can be written as the difference of a into b. So we are done now. So that means I can therefore write S is nothing but summation over tan inverse of 2 raised to the power r minus tan inverse of 2 raised to the power r minus 1. R goes from 1 to n here. Okay, so now just you have to go on putting the values of r from 1 to n. Consecutive terms will get cancelled. So let's say we put tan inverse of r as 1, so tan inverse of 2 minus tan inverse of 1. That's the first term, plus tan inverse of 2 square minus tan inverse of 2. Okay, similarly dot dot dot. See, even if we don't write it, because this is, I think, the third question we are doing using this method where we broke the general term or rewrote the general term as difference of two consecutive terms. So now we know what are we going to get. So the first term that gets cancelled is tan inverse of 2 here. So that means the rest of the terms will get cancelled because tan inverse 1 can't get cancelled. Now see, we are left with one term in the beginning, and that is negative term. Okay, so we got negative term from here, so we'll be left with what? Just one positive term from at the end, and we'll get it when we'll put n here, bachcho. Okay, so we don't need to, we are not required to write it completely. We can, if we have that observation, we can write it directly. Okay, so this is nothing but tan inverse of 2 raised to the power n minus tan inverse of 1, which is nothing but pi by 4, and that should be the answer. So that's the third question based on what I feel as the most important method for solving the series, and that is breaking the general term as difference of two consecutive term, bachcho. Okay, so that was the question for today, bachcho.